Welcome to Advent of Code. Merry Christmas. Day 25 is just starting. This is usually an easy problem, and I managed to backfill all the stars. All right. So we got, hmm, it's sort of balanced base 5. We're going to convert from that to decimal. All right. Let's grab our example. All right, so let's write uh, okay. So 1 is 1. Oops, didn't get that right. Okay, 1 is 1. Oops. 2 is 2. 0 is 0. Equals is -2, and minus is -1. All right. Anything else we'll mark as a 0. Maybe we could go back and write a okay. So we could reverse the string. The, so yep. Okay. So um, okay. So if we've got a single digit, Then we calculate snafu digit of that. Otherwise, we calculate snafu digit of x, and we calculate S2D. Okay, we can just do the empty list since we're doing it in reverse order. So 5 times SGD of the rest of it. All right. So the hard part is doing the other direction. So I'm gonna look. I feel like I should be able to do this, but I'm gonna look at the balanced ternary Wikipedia page. It's the same idea. Conversion. Oh, this is completely useless. Who the heck wrote this? Add one. Okay, add one digit by digit from the first non-zero trit with carry. And subtract one trit by trit with the same trit without borrow. I see. Okay, so if we had a number yeah, we can subtract So if we add with carry but subtract without carry, then the result is between 2. Okay. Um, so once again, we'll reverse the result of decimal to 5 of n, where decimal to 5 of 0 is 0. Decimal to 5 of n equals n mod 5 is the units digit, and then we do decimal to, oh, there we go, decimal to 5 of n divided by 5. Why doesn't it think that terminates? Okay, okay, so we need to assure it that this only works on positive numbers. Are they all positive numbers? I think so. Looks like it. Oh, I've got a, let me change the variables just for clarity. All right, and it's integer. All right, that seems, oh, something's thrown up an error. Ah, there we go. Still has termination error. Why is that? Seems to me like n should get smaller every time. Oh, All right. We just had to tell it what the type was, I guess. Because there are a lot of things that we could apply mod and div to. And just because it's decreasing doesn't mean it's will ever hit 0 for some of them, I think. All right, so let's do base 5 to snafu. Okay, so we're going to do the operation above. We're going to add with carry and then subtract without borrow. So keep thinking there must be an easier way to go about this, but I can't come up with it, so we're just going to go with this Wikipedia derived procedure. Okay. Uh, all right. So add with carry. So we need to so that gives a carry and a result. So we're just going to append those together. On how much? Oh, okay. First from the left. All right. It doesn't matter if there's zeros on the right. All right. So add with carry of uh, okay. So when we get to the end, it's an empty list. Otherwise, we do the addition. Oh, it's no carry. Yes. So then we do this digit, so um, carry plus digit plus 2 mod 5. The new carry is carry plus d plus 2 divided by 5. And that's going to be, and so the new result is new carry, comma, out, colon, rest. Okay. Subtract without borrow is just mapping -2. Hi, Gnarf. Is it a hard G or a soft G? I've never asked. All right. Done. All right. And we just need the reverse of this. Yeah. This looks like it's going okay. All right. So we can tell Liquid Haskell that this should only be called with an integer. It's at least -2 and less than 2. Returns a character. So we're probably gonna have to add some types here. I'll subtract without borrow 2. Go. Carry. Hmm. Why does it think it's from a list of integers to a list of integers? A list of integers. All right. add with carry is from a list of integers to a int and a list of integers. And in liquid Haskell, it's from okay, so these are natural numbers n less than 5. So these are the same. So this should be n less than. All right, what's our maximum carry? It should be 1. 5 plus 2 plus 1 can't be 10. And a list for original type. So we should probably have defined a type for this. All right, let's do that. Yeah, I thought about it for like 30 seconds. I couldn't come up with a better one, so I went with the Wikipedia balance ternary, and this is a terrible explanation, but it is an algorithm which can be adopted for balance base 5, whatever the word for that is. I completely believe you, and I couldn't. I confuse myself whenever I think about that. Right, the normal algorithm should work. That if you got a number that's too big, you just slough it off for the next. No, see, I don't know how to do it. um, all right, let me think about this. So if digit mod the digits value, then subtract your digits value. All right. So what you're saying is we take yeah. I'm sorry. I don't get it. That's on me. Yeah. Okay. So this takes a. Okay. Okay. This returns base 5 digits again. We're gonna get rid of this. We already did. Okay, so subtract goes from base 5 digits to I just tried to use LaTeX. It's been a long day. Merry Christmas. What was I even writing here? I think I got distracted. All right. And okay. So it doesn't like this. This is the problem again is map. Okay. Let's tell it that's I'll take a look if can't make this work. So 5. Oh, all right. I think my base 5 definition is no. So if we're greater than 0 and less than D, then if we subtract 2, we should be greater than equal to 2, and there it is. There it is. Less than or equal to 2. Okay. So it's not nearly proof of correctness, but let's try it out. Oh, interesting. So it doesn't let. All right. So if oh, but we checked it. We just checked it there. Okay, and it's always a bad sign when I'm arguing with the type checker about equality. Yeah, I looked at that and so I didn't. So I didn't worry about that, but I still need to convince. But I encoded that as part of the assumptions, and so I need to convince it. But it wasn't taking some nums in both places. It only takes a variable name both places, which seems odd. Okay, stack run day 25. 906, 198, 11. Okay, looks good. I got some sort of base case problem here. Okay, so if it's 0, okay. If carry equals 0, then blah else. Go. Great, let's grab our input. Hurrah! Thank you. That's my first 50-star year in a while. So both 2014 and 2015 I was in a different account. I don't remember what language I used in 2017. Huh. So, yeah, one of these years I was using, I think it was 2019, I was using a graph grammar language and I couldn't write a multiplier. And everything was, half the puzzles are based on int code. And this year I was trying to use pi, which is not a real language. All right, let's take a look at this. Okay, so we look at the digit. If it's 4, that's too big. So we're gonna have to roll over to the next digit. We subtract 5, we get 1, we put in the digit for 1. There's 3, still too big, we subtract 5, we get -2, we use that as the digit. We add those back in. We carry them to the next place. Okay. Yeah, so let's try this out. All right, so if y is greater than or equal to 0, if y is less than or equal to 2, then we can just use that digit. And we have, it doesn't matter that whether we subtract it, it just rounds down. So otherwise, we're going to have to do y minus 5. And we're going to have to add 1. Wow, I didn't like that at all. So 3, 5 minus y. There we go. Okay, yes. So we're sort of doing a carry. Minus minus 5 minus y. Yes. Yeah, we want a negative number there. So that's the same as negative 5 plus y. Yes. Okay. So we add 1 to the next place, and we balance that by adding a minus 5 in this digit. All right. Yes. So now those are balanced. All right. So if we're up for a challenge, the challenge is proving that these are inverses. So all right, let me try. Oops, I didn't do the digit conversion, but 2 minus 2 0 minus 1 0. Yeah, that looks pretty good. All right, looks good. So let's try to write a quick proof. So let's Yuck. Presence reverse is going to make our proof hard. On the other hand, we use it both. Yuck. I changed my mind. It's too difficult to prove on late Christmas Eve, almost Christmas Day. Anyway, thanks for the help. Took me about 40 minutes, I think. Oops. So how fast were the fastest ones? 8, 8, sub 8 minutes for both places. Oh, all right. Well, it's our best showing yet, and probably not many people working on it on Christmas Eve. So, okay, yeah, you too. Merry Christmas, everybody. Good night.